everybody, this is Miss McClellan here to go over IM2 Notes 1.1.2 with you. How can I describe it? We have two learning goals. They are, and we'll say them in first person. 1, I will be able to use formal vocabulary to name polygons such as quadrilateral and trapezoid, for example, and attributes of polygons such as parallel sides and right angles. And number 2, I will be able to mark diagrams to communicate attributes such as equal length, congruent angles, right angles, and parallel sides. Okay, let's go. We start with problems 112 and we're combining it with 113. We're going to list the attributes of each polygon from our polygon bucket in the last lesson. We consider the number of sides, sides of equal length, whether or not sides are parallel, and if angles have equal measure. We're going to disregard symmetry for now. So for each shape, we'll be marking the diagram for each polygon figure, and we'll list any attributes that we can come up with. The first shape is scalene triangle. Now a scalene triangle doesn't have any parallel sides, it doesn't have any sides of equal length, and it doesn't have any angles of equal measure. It has 3 sides and no congruent sides or angles. Next, a scalene right triangle. This is a scalene triangle where one of the angles is 90 degrees. So it has 3 sides, no congruent sides or angles, and one 90-degree angle. Okay, isosceles triangle. This again has 3 sides. It has 2 congruent angles. I'll mark those with pink. And 2 congruent sides. I'll mark those with blue. Okay, next we have isosceles right triangle. This is an isosceles triangle where one of the angles is 90 degrees. Again, this has 3 sides, 2 congruent angles, which I will mark pink, 2 congruent sides, which I will mark blue, and 1 right angle. Okay, we have an equilateral triangle. This again has 3 sides, 3 congruent sides, which I will mark blue, and 3 congruent angles, which I will mark pink. All 3 of those angles have equal measure. Next, we have a quadrilateral. That is any 4-sided shape. Moving on. A trapezoid has 4 sides and 1 pair of parallel sides, which I will mark green. Notice that for parallel, I'm doing a little arrow. That's different than what I would do for congruent, which would be just little tick marks. Next, we have isosceles trapezoid. Again, we have 4 sides, 1 pair being parallel. I'll mark that green again. And it's isosceles, so we have 2 congruent side lengths. So 2 congruent sides. These 2 sides have the same length, and I'll mark that blue. Next, we have a right trapezoid. Again, we have 4 sides, 1 pair of parallel sides, and I'll mark that green. And since this is a right trapezoid, we have 2 right angles. Next, we have a kite. Again, we have 4 sides. We have 2 pairs of congruent sides. And now we get into single and double tick marks. The double tick marks are congruent to one another, and the single tick marks are congruent to one another. And opposite angles are congruent. And I'll mark those in pink. So 1 pair of angles will use a single angle marking, and the other pair of congruent angles will use a double, which is which shows you which angles are congruent with which. Next, we have a parallelogram. Again, we have 4 sides. We have 2 pairs of parallel sides. We have opposite angles are congruent. 2 pairs, opposite angles are congruent. And that's it for this one. So and opposite side lengths are congruent. Okay. So for the side lengths, I'll do that in blue. I will do the angles in pink. And I will do the parallel sides in green. Okay, next we have a rhombus. Again, we have 4 sides. We have 2 pairs parallel. Opposite angles are congruent. And the only difference between a rhombus and a parallelogram is now opposite sides, while congruent. Actually, all 4 sides are congruent. Okay, so I'll mark the sides in blue. All 4 side lengths are the same. I will mark the opposite angles in pink. And I will show parallel in green. Moving right along to rectangle. So a rectangle has 4 sides. Opposite, 2 pairs are parallel. 2 pairs. All angles are right angles. And opposite sides are congruent. I'll mark the sides in blue. I'll mark the angles in pink. I'll mark the parallel in green. And then we move on to square. A square has 4 sides. 2 pairs are parallel. All right angles. And all sides congruent. Okay, I'll mark the sides in blue. I'll mark the angles in pink. I'll mark the parallels in green. Oops. Put the dot on the previous problem. Okay, almost done. Let's do regular pentagon and then regular hexagon. So our regular pentagon has 5 sides. All sides are congruent. And all angles are congruent. In fact, that's what regular means. Regular n-gon would have n sides, all sides congruent, and all angles Okay, so let's mark these. I'll do the sides in blue for the pentagon. And I will do the angles in pink. They're all the same. And then let's do the regular hexagon. Hexagon has 6 sides. It's regular, so all sides are congruent. And it's regular, so all angles are congruent. Let's mark that. That's for the sides, and then I'll use pink for the angles, and I forgot to put a key on the last problem, so I'll update that as well. Okie dokie, moving on. Okay, problem 1-14. We examine the Venn diagram. Some of the polygons from the polygon bucket have been placed in the regions based on the two unknown attributes. What do we think condition 1 is? What do we think condition 2 is? Let's take a look. So for condition 1, the first thing I notice is that they're all triangles. What do all triangles have in common? 3 sides. All triangles have 3 sides. Okay, I think that's it. I think condition 1 is that it's a 3-sided polygon, as in a triangle. What about condition 2? Well, okay, I think I see it. I think for condition 2, it's that all of these have at least one pair of congruent sides. They all have at least one pair of sides of same length. Okay, part B says, where would a regular hexagon, so regular hexagon, belong in the Venn diagram? If you don't know, a hexagon is a 6-sided regular shape. So it's got 6 sides, all sides congruent, all angles congruent. I'm just going to draw it right here so that we can have that for reference. Pretend all of my angles are the same. I'll make it so by marking them, and all side lengths are the same. Okay, does it meet condition 1? No, because it has more than 3 sides. So it doesn't meet condition 1. Does it meet condition 2? Yes. At least one pair of its side lengths are the same. So only condition 2. I know because it has at least one pair of congruent sides and more than 3 sides. Okay. Next, I'm being asked, where would a right trapezoid belong? So here's a right trapezoid. Does it have more than 3 sides? Yes, so it doesn't meet condition 1. Does it have at least one pair of congruent sides? Not necessarily. So I think this would go outside both conditions. I know because it has more than 3 sides and it can have all sides of different lengths. Okay, so let's draw another polygon that belongs outside both circles. So I need more than 3 sides, and all sides have to have different lengths. I think I can do it. Do. That's not obviously correct. This side longer. There. It belongs outside both circles. It has more than 3 sides. And no 2 sides have the same length. Period. Let's continue. Almost done. Okay, let's look over some math notes. We're going to fill in these blanks. Just like we want to be able to mark our diagrams according to some convention so that we can easily communicate with one another, we also want to be able to name geometric figures according to some convention so that we can communicate with one another. So that's what we're going to do here. In the word bank, we have what we'll be naming, and then we're going to match those names to their descriptions. A blank is named using a single capital letter. That's a point. For example, D is a point here. A line, which extends infinitely in 2 directions, is named using any 2 points on the line. So for example, line on the right could be DE, and you put on top of it a line with arrows going in both directions, ED or EJ. And there are other ways too that we could do it. So I'll take this out of the hard copy of notes. Okay, a blank is the portion of a line between 2 points. A blank is a portion. Another word for portion is segment. This is going to be a line segment. And it is called, and those points are called endpoints. So in the diagram, there's a line segment between E and J. That would just be this part. And it would be referred to as either EJ with a line on top or JE. Notice this does not have arrows, and that's because we end at the letters E and J. The point on a polygon where 2 line segments meet to form a corner is called a vertex. The plural of which is vertices. Let's cross out vertex and endpoints. Polygons are named by their vertices. For example, the vertices of triangle ABC are points A, B, and C. The angle at vertex B is written either as angle B, and the measure of angle B is written as M angle B. The length of side BC is written as BC. So in triangle ABC, the measure of angle B is 80 degrees, and the length of BC is 2 centimeters. A blank is a part of a line that starts at one point and extends infinitely in another direction. That's called a ray. For me, it helps to think of a ray of light. Starts at the sun and it goes forever. A ray is named by its endpoint, followed by one other point on the ray. So, for example, in this diagram, if G were the sun, Mr. Golden Sun. Okay. We would have GF is a ray, GH is the ray starting with G going in the direction of H, GI is the ray starting at G going in the direction of I. For naming rays, for lines and segments, order of the letters in the name doesn't matter. But for rays, when we're naming rays, we always have to start with the endpoint. Now, an angle is formed by two rays joined at their endpoints. The measure of an angle represents the number of degrees rotated from one ray to the other about their common endpoint, known as the vertex. In the diagram above, there are several angles and vertices. This is the diagram we're talking about. When this happens, an angle is named with 3 letters, and the vertex must be the second in the name. So, for example, the angle measuring 10 degrees is IGH or HGI. Importantly, G is in the middle. That's all for our notes today. I hope you have a great time. Let me know if you have any questions, and I'll see you next time. Thanks, everybody. Bye.